Thank you all for joining today, our webinar where we're going to talk about reducing scrap with GelSight. I'm Abby Lindberg. I'm Director of Applications Engineering here. And just before we start, I'll talk about a couple housekeeping items. We'll be recording this and uploading it to YouTube after this for anyone that might have missed it or wants to watch it again. And we will also have we'll have the chat going. Still running into some issues, I think, with the Q&A. So you might see that as inactive, but we enabled the chat for this. So feel free to ask questions throughout the webinar in the chat, and we'll get some time at the end to answer them. Frank Chan from my team will be answering questions live from the chat throughout. And with us today, we also have Mark Seeger. So I'll pass it over to him to introduce himself and really talk about reducing scrap with GelSight.
Great, thanks, Abby. Yeah, hi everyone, I'm Mark, and I work primarily with customers in the Midwest and Northern US. I had previously worked in some of the other regions, but as GelSight continues to grow, we continue to add more good people. And so I've been primarily working in this part of the country and really working with customers in a variety of industries where the inspections and the measurements that get done are just critical to the operations. So aerospace customers, avionics, the nuclear industry, medical, automotive, all these industries and many more, but these are just some examples of where the actual measurements are super critical. Working with both OEMs and maintenance operations, as well as their supply chains throughout. And really a lot of the testing is on, or a lot of the inspections are on structures, subassemblies, components, and across a wide variety of different materials. So different types of metals, compound metals, composites, 3D printed parts, transparencies. The GelSight technology is agnostic to any kind of reflectivity or transparency of the surfaces under test, as well as agnostic to any kind of ambient lighting conditions. So that gets us into a lot of different applications as we've been adding new capabilities and growing the suite of measurements that we're able to do. So one customer in particular that I'll mention here is Kalitta Air. They're a world-class air cargo company up in Michigan, is where their headquarters are. And they've got an extensive MRO operation that does maintenance and repair on a variety of components that are comprised in airplanes. So the area that I was working with is what they call the power plant, and that is where all the engine maintenance is done. And many thanks to both Fred and Joe up there at Kalitta for sharing their story, or allowing us to share their story with some of our customers and just give some examples of some of the value that GelSight was able to provide. In this one case, there was it was an engine blade, jet engine blade, and there was some excessive gouging and excessive wear due to some the way that it was just operating in the engine, and that specific failure, or that specific, I guess failure is the right word. It had a tolerance of 4 thou. So if it was beyond 4 thou deep, it would be a fail. If it was under 4 thou, then the part would not have to be scrapped. It would have to be reworked, or could get put into service, or whatever the specific details were. But it represented a real challenge because, as you can imagine, a blade, it's highly reflective, it's curved, and it's just very difficult to get consistent results with typical tools. Maybe a depth gauge or pins or other type of hand tools really proved challenging. So the folks there at Kalitta Air wanted to get a second opinion, and that's how GelSight got involved. And it was especially important because those blades, as you can imagine, they're very expensive, right? They're over $50,000 to replace. And so, by scrapping one, that's a really big decision that's got a lot of costs associated with it. So the GelSight system, the one that Abby's going to be showing, has a traceable accuracy of 0.2 of a thou. And so compared to the spec, the pass-fail spec of 4 thou, we had greater than 10 times headroom. And so that accuracy coupled with the repeatability of the GelSight system, really helped prove that the damage that was seen and measured with other instruments and other tools was actually well within tolerance. And so they didn't have to scrap those blades. And so it turns out there were about half a dozen blades or more. And so the savings was well into the hundreds of thousands of dollars very quickly that GelSight was able to help out with and help enable them to not have to scrap those parts. So I think Abby's going to give a demonstration of the capabilities of the GelSight system in that application.
Thanks, Mark. Yeah, so I'll actually stop sharing this slide here. And before we get into the actual application, I'll talk a little bit about how GelSight works for anybody that might be joining for the first time and hasn't seen the system before. So we'll be using our Series 2 system, and then I'll also get into our modular system. We'll talk about that a little bit later, but the actual principle of operation is going to be the same across both of them. And what we've got here, we've got one button on here, and inside of this system, we have a camera and an illumination system. We've got 6 banks of LEDs, and when I click the button, I'm taking those 6 images, and the 6 different lighting orientations let us create 3D data from those images. And in conjunction with that, we have our gel sensor here. And this conforms to the surface and then has this pigment layer on it, which is really what gives us the ability to look at those surfaces regardless of their optical properties, that Mark was talking about, highly reflective materials or transparent materials. They all look the same to the GelSight system, really providing kind of an advantage here for those challenging surfaces. So I'll just attach the gel back into the system here like that, and then we'll get connected. Before I switch my video, I'll hold up the first sample that we're going to look at. We're going to look at this blade. We got a couple of gouges on the side here that we'll take a look at. And then I think we'll also look at a defect on an edge here as another common application for blade defect inspection. So with that, I'll share my other video so we can see the scans being taken. So I'll switch that over. Let's see, we've got that video. And then I'll also go ahead and share the GelSight mobile software. And as I share that, if you want to see the GelSight mobile software larger and the video smaller or vice versa, you can switch back and forth between them by clicking on the display. So if you want to see the screen share larger, click on that. If you want to see the video larger, click on that. All right, so I'll just go ahead and click go live here in the software so you can see the live output. And the first thing that I'll do is actually just press my fingertip into the top of this to give you an idea of the resolution here. And next I'll go ahead and take a scan of the gouge on this blade. So we'll look at this. I actually don't know how well the defect comes across in the video, but you'll see it in just a second here through the GelSight view. I'm just going to press this onto the surface, something like that. And we'll click the button to take that scan. And now our 3D data is generating. You can see it should be available in just a couple seconds here. And we'll open that scan up. And the first thing we like to do is look at that in 3D. So I'll click 3D and we'll look at that defect here. And I'll switch back to analyze. And what we've historically been using to analyze defects like this has been our scratch function. So I'll start with that. And what we'll do for the scratch function is we'll draw 2 boxes. We'll draw one around the scratch and then one around that and some of the reference surface. Kind of just come in here and snap these to the edges here. And we'll click Analyze. And then the blue dot that we're getting is the deepest point of that defect with respect to the reference surface. And the reference surface is what's outside of this first shape and inside of this second one. And so this can really handle that complex geometry of that blade. And let's take a look at this deepest point here. So this blue dot. Maybe, in a lot of applications, we don't stop here. We might want to know what the radius is at the bottom of that defect. Depending on the radius at the deepest point, might be where a crack could propagate. So oftentimes our users are interested in that as a spec as well. So I'll show an example of that. I'll come in here. I'll just grab our radius tool. And we'll draw a line across that defect there, or the deepest point where that was highlighted from the scratch function. And then I'll come in and I'll just define where I want to fit my radius. Go here. Oh, I got it. The Teams video is in the way. There we go. Now I can click it. All right. And I'll fit our curvature to that right there. So we can see the radius being output. That's going to be the radius at the bottom of our scratch. And now I can just turn this into our PDF report and kind of customize that view. Maybe we'll zoom in on the 3D, something like that. We can see the output in the top corner here. We've got that minimum point. And we can also come over here and see the output of our radius measurement. So kind of just quickly turning that into a PDF report and showing that workflow. But I did also want to talk about our defect detection function for this type of application. So starting in software version 4.3, our latest release that I'm running right now, we also have the option to use defect detection on surfaces that aren't just flat surfaces. So we can use defect detection on something like this on the side of a blade. So I'll come in here and I'll define a reference, or I'll define a search region, but we could run this on the full field of view or a region of interest. And we'll click Analyze here and take a look at that output. So the defect detection analysis function is going to give us the characteristics, length, width, area, volume, and depth of the deepest defect in our field of view. And then, of course, that can turn into our PDF report as well. And if we have all of these, it'll just be the third page here. So kind of customize that. So also on this blade, we could take a look at an application on the side of this blade. We've got a defect right on the edge here. And this is something that's typically challenging to measure with a bunch of other systems, and really just the actual fixturing involved in measuring a defect on an edge like this. It can be pretty challenging for a bunch of measurement systems. So I'll just come in here and I'll press the gel right onto the edge of that, something like this. And I'll click that button to take the scan, just like we did with the flat side of the blade. And we'll open that scan up and we'll take a look at it in 3D as well. This one's pretty interesting in 3D. You can kind of see that big piece missing there. We can also scale it up and see it even better. I think this is kind of a fun one. So we'll take a look at that. And we'll jump back over, and for defects on edges, we want to use our offset function. It's basically a profile function. So we're going to draw a line across this defect and we'll get the profile. So we'll come in here, we'll click offset, and we'll draw a line just like that. And we can see the profile. And we'll tell it what our reference surface is. We'll say, we've got some reference surface on either side of our defect here, like that and that. And maybe we want to measure the average of the reference surface to the deepest point along that profile, the minimum point here. So we can see the depth here is about 9 thou. And in this case, the offset's going to give us the depth measurement, but maybe we also want to include the length and width of this defect in our report as well. The defect detection function was great. It gave us that in an automated way. But here we'll come in and we'll just take a couple simple measurements on the image here. I just clicked our ruler function in the bottom left corner. And I'll just draw one line across for width. And I'll draw one line. We'll add another one here. I'll draw one line along it for length. And now I'll even right click on these. I'll add an L for length. and we'll come in and we'll add a W for width on this other one. Like that. And now we'll turn this one into a PDF report as well. And the nice thing about adding those labels here, we can see them on the image, but we can also see them in the top corner here. We've got our offset, so our depth measurement, and we've got our width and our length specified in the report as well. I'm going to customize how we want to see that 3D view too. So the next sample that I have on the desk here that I'm pretty excited to share is actually this fuel pump drain. And applications like this have been coming up a lot for us in the past year, especially for scrap reduction. So Mark, do you think you could talk a little bit about tube shop applications that we've had? And Mark, you are muted right now, so.
Thank you.
Perfect.
Yeah, so this is actually a really good application for the new modulus probe we have because of the complex geometry of that fuel line. One of our customers purchased some GelSight systems, and as soon as they came in, as soon as the GelSight systems arrived, one of the leaders of the repair shop asked one of the inspectors to go out to the scrap bin, and the scrap bin is this big area. It's probably 20 feet by 20 feet, maybe even larger, that it just holds parts designated as scrap, tagged as scrapped, before they're finally thrown away. What that leader asked the person to do was to just take the GelSight system, go back into the scrap bin and re-inspect everything, just to make sure, just to do a double check that those parts were really scrap worthy, right? It turns out that they're able to salvage over $250,000 worth of parts that were designated as bad, but they really weren't bad. And that was just over the course of the first 2 weeks. So these people were pretty excited about that because they got immediate payback on that GelSight system. But then also, as they started using it more and more, what they saw was on an ongoing basis, they had a separate problem, which was their repairs. When they would return the parts to the end customers, 65% of those parts would be rejected by the end customers. And so, I'm sorry, what they saw was a 65% reduction in the repairs that were rejected by their end customers. So, for every part that would go out, then they were able to really make sure that that part wouldn't come back. And so by reducing their returns and their end customer rejection 65%, that was a pretty big impact to their overall bottom line. And again, these were errors that were flagged as pass, meaning they're good, but they actually failed. So it was the opposite of the problem that the scrap bin had, right? The scrap bin said, you're failing good parts. In this other dimension that the same customer had, they were actually passing bad parts, and so GelSight was able to help out with that as well. So I think that's what Abby will show, kind of just a good example of exactly what some of those failures, what some of those defects look like on pipes and tubes.
Yeah, thanks, Mark. So I've got in this case, I've got this fuel pump drain, and you can see the kind of the geometry of this, right? So this one has a defect right in this sort of elbow bend, and this is something I can't even access it with our Series 2 system. But what I will use for this is our modulus with the straight lines attachment. So I'm just going to swap in the software which system I have connected. I'm just going to disconnect my Series 2 and connect the modulus, and we'll see that pop up in just a second here, searching for the device. All right, here we are, ready to go with modulus now. So I'm gonna take the straight lens here, and I'm gonna find the defect right in the sort of elbow corner. And you should see that on the screen pop up in just a second. Maybe we'll look at like this area here. Yeah, I'll go here. And I'll just click the button to take that scan. And we'll get that 3D in just a second. We'll go open that up and take a look at it. So here's the scan that we just took, and I'll select 3D here, and you can really see the geometry of that part here. So you really get the effect of looking at it in this elbow area. So I think this is, honestly, I just think this is kind of cool to look at. And then we'll just come back over and we'll use our defect detection function to measure the depth of this. So I'll come in here and I'll select defect detection. And I'll define a region for it to look for the defect in. And I'll click Analyze. And the output for this is going to be those characteristics of that defect. Again, you can see this is just under 2 thou deep. And we also see that profile through the deepest point. And then, of course, this quickly gets turned into that PDF report. And for that application that Mark was just talking about, where our user was reducing rejected repairs using GelSight, they were basically attaching GelSight reports to their repaired parts, kind of to help with that process. Like, we have quantified what this repair is. So that having the ability to just quickly save or send off this report has really been a benefit to our users here. And kind of the next step after this would be automating the decision making a little bit further, just by adding pass-fail criteria to this as well. So I'll come in and I'll click Configure and Analysis. And I'll select defect detection again. And maybe we want to add pass-fail criteria to the depth. Maybe I want anything over 1 thou to fail. So it says any value of 1 thou or lower will pass. So I'll go back to Analyze here and we'll just rerun the analysis function for that change to take effect. And you can see all that red, that UI indication that this is a fail. This part is now failed. We can see the depth value exceeds the upper limit and all of this kind of red result here. And you also see that carry over into the PDF report too. So once we open that up again, we can see the pass-fail status is fail, and we can see that same message again that says depth value exceeds the upper limit. So I think with that, I'll pass it back over to Mark to kind of summarize what we just talked about and the value that GelSight brings to these applications. And I'll have him get off mute again. So.
Oh boy, yeah. Thanks, Abby. Yeah. So really, I think in these examples, what it really boils down to is, the GelSight's able to help customers stop failing good parts, and then also stop passing bad parts. And in the case of failing good parts, that leads to excessive scrap and just bloated overall operational costs and higher cost of goods than normally should be there. And of course, that impacts bottom line profitability. Passing bad parts ends up, it's got a lot of cost implications as well, but then also it results in customer returns, and that impacts the company's reputation, right? So, there's a lot of implications, both hard, numerical, and then softer ones. And it's often the softer ones that are more difficult to recover from. So I think these are just pretty interesting stories from that standpoint, that just the impact that GelSight's able to have, and have very quickly. Customers put these systems into work very quickly, and often get a very fast payback on the investment. So that's really what we strive to do. And every time we release new software, it's based on customer requests that we get. And so what we try to really do is have a good process in place for capturing voice of the customer. So anybody on this call, if you're a GelSight customer now, certainly if there's something that you're seeing that you'd like the system to do at some point, please give us a call, contact Abby or your local GelSight person, and we'll be happy to talk with you in some detail.
Awesome. Thanks, Mark. So with that, I think we have some time for questions at the end. I know Frank's been answering them in the chat throughout. So go ahead and use the chat to ask any questions that you might still have. And I'll kind of go through even the ones that Frank has already answered in case they might be relevant to some of the rest of the group that's not in the chat right now. So we had the first question that we had was if we're able to show where on the 3D display the measurement is located. And the answer is not yet. So right now, you'll interact with the 2D display, and the 3D will be kind of separate from that. All of the measurement results are performed on the 3D data, not the 2D image that you have in the display. So we do reference that 3D data for all of the analysis. All right, and then let's see. We had another question that said, is defect detection on the tube automatically finding a reference surface? Yes, so the defect detection function is automatically finding that reference surface. And I mentioned, with our more recent software version, 4.3, that's when we did make a change to that reference surface calculation, which allows us to do these curved surfaces with defect detection, which has been really great because of how automated it is.
Yeah. And Abby, there's a fourth order polynomial fit gets done, right?
Yeah, so when we're doing the scratch function, that's definitely how that's happening with that reference surface there. And then the defect detection is doing something similar. Mm-hmm.
Great.
And we have another question that says, is there a calibration setup? Yeah, great question. So we do calibrate each gel before we can use it. So basically each gel, and this is a consumable, you do replace this. You just need to calibrate it before you can use it. It's user calibratable. So it's about 6 scans and takes a couple minutes just to calibrate each one of these. And you also don't have to calibrate them each time you connect them to the device. So you can calibrate a bunch of gels and then just drop them in when you need them. And then can we go over the application regarding arc welding and as welded high pressure piping? So I think we would like to hear more about your applications. I think we'll follow up with that specifically after this. I'm assuming we probably have some tools that'll be relevant to you, especially offset and some of these other ones that we've had. Kind of depends if you want to look at quality or defects, but we're happy to follow up with you after this to go over that.
Yeah, for sure. Yeah, there were some questions from that same person about tagging the report to find the location on the parts. So yeah, that's a much deeper conversation to have for sure.
Mm-hmm. All right, and then just a couple questions in there about will we be recording? We are recording this, so we will be posting it to YouTube, and you'll see an email go out shortly with the recording once we've got that uploaded. All right, so I think that's all we have for questions in the chat right now. So once again, thank you all for joining us today.
Very good. Thanks, everyone.